Hey everyone, my name is Gil. I'm a front-end developer in Wix. I joined Wix around 2.5 years ago, and in Wix I'm a part of the group that works on the site renderer. So the site renderer is the application that renders all the Wix websites. It renders around 50 million websites in a day. And today we're going to build a simple site renderer from scratch, and to show you how our site renderer is implemented, or how we, and also to demonstrate the challenges that we face while we are developing it. I know that a site renderer application might sound like a unique application, but you'll be surprised to know that the challenges we face are actually very common, and I'm sure that most of them will be relevant to you. So, like I said, I'm from the site renderer group, and in this group I'm a part of the platform team. In the platform team we enable users to extend the functionality of their Wix websites. Using adding JavaScript code, users can fully customize their websites. So we run the code that our users write to their websites, and we also build SDKs. So that using the SDK, basically the code can interact with the Wix sites. And I'm going to show everything in the live demo. By the way, this feature is a part of a big product called Wix Core Vid. It's a set of developer tools on top of the Wix ecosystem. And if you want to know more about Wix Core Vid, you can basically just search for Wix Core Vid to get more information. So before we start the live demo, I want to show you one of the most important products in Wix. It's the site editor. The site editor is basically the place that the user creates their website. So I created a simple site for this live demo. So I added a button, a text, and an image. And when I click publish, a JSON representation of the website is saved somewhere on the internet. Let's take a look at this JavaScript object. So it's a very complicated object. It includes everything that I added and edit in my website. So I have here somewhere a component that's called site button. And if I'll search for the label that I gave to my button, it's also somewhere here in this big object. It's basically a JavaScript object representing everything in my website. So this is basically the output of the editor. And another output of the editor is the code that I can add to my website. So in the editor, I can basically write any JavaScript code that I want, and to fully customize my website. So I added a simple line of code here. Obviously, you can write any JavaScript code you want. In this JavaScript code, I basically changed the text of the text component, and I access the text component from the ID of the text component. It says text1 on the bottom, on the top right corner, and that's how I access the component. So this is another output of the editor. Once I publish my site, this code is saved somewhere on the internet. So both the user code and also the JSON representation of the site, both of them are the outputs of the editor, and also inputs for the site renderer. So the site renderer takes those two inputs and render the website. And that's exactly what we're going to do also in our simple application. Our simple site renderer is going to take those two inputs, render the components, and also run this code and actually render the site. So let's see, first of all, this is the site, the Wix website. Like you see, it renders the component and also ran the Wix code. We changed the text component to it works. But the only difference that we're going to use a simple JSON representation. Like you see, this object includes a lot of information about my website that we're not going to use. So instead of this object, I created a simple object. Let's take a look at it. So a simple array of components that I'm going to use. That's what I'm going to render. It's basically an array of objects. Each object contains the structure of the component. So this is the the structure of my website. And let's take a look of those, the fields that each component has: a comp ID, a type, I have a button, an image, and a text. It has the Wix code ID. This is how I select the component using Wix code. I'm going to talk about it later in the live demo. Each component has a data. The button has a label, the image has a source, and the text has a text. And also a layout, the X and Y, exactly where I put it in the editor, and also the width and the height. So this is the structure of the component that we're going to use to render the site. And another input, this is one input of our application, and the other input of our application is going to be just this Wix code that I'm going to run later in the live demo. So from those two inputs, we're going to render the Wix website. And again, it's obviously going to be a simple site renderer, but you can imagine that our site renderer is much more complex and handle much more of use cases. But during the live demo, I'm going to talk about all the challenges that we face when we develop our site renderer. So let's get started. First of all, I'm running the application here. I'm serving all the code that I'm writing here in this window. Everybody can see this. We're going to use the console log for logging. So make sure you look in the top right corner. Is this big enough for everyone? Great. So let's get started. Or start. So the first thing that I want to do is I want to fetch the component's structure from the internet. Like I said, when I click publish, the editor saves the structure of the component somewhere in the internet. And in the real world, maybe I'll have the server will send me this URL, but in our example, it's basically just going to be a URL that's served in my localhost. So I'm going to use fetch to get it. And it's going to be a JSON, so I'm going to transform it to a JSON. Let's see that I have my components here. Okay, so I got my three components here, and now I'm going to use them to render the site. So now, the way that I'm going to render the components to write the UI is using React. I'm going to import React. And I'm going to, we're going to implement a React component that it's going to render those component structures. So we're going to implement a renderer component. I haven't implemented yet, but once I'll implement it, I'll pass it the components object, the components array, and I'm going to render it to the DOM. So now we're going to implement this renderer component. It's a React component that gets our components array and renders the component, and I'm rendering it into an empty div in the DOM. So let's implement the renderer. So this is the renderer code. The renderer is a simple React component that takes the components array. And now what I want to do, I want to loop the components array, and for each component structure, I want to render a React component that is corresponding to the React component, to the component's type. So let's see how I do it. First of all, I'm going to return here a div, a wrapping div. And now I'm going to loop the components array. For each component structure, I'm going to have a mapping between a component type and a React component that we're going to develop. And so this object is going to give me a React component. just call it viewer components. It's going to get, the key is going to be the comp type. Each component structure has a comp type, and it's going to give me a React component that I can render here. And I'm going to pass it the entire component structure so it can use it to render the component. Now let's write the viewer components object. So it's a JavaScript object. It has the keys button, image, and text. Oops. And a button is basically just a button. And first of all, it's a React component that receives the props and renders a button. And since I have the entire component structure here, I can put the components, the props data label from the component structure for this button. It's going to be the label of the button. Let's implement the image. Image is a simple image with the source is from props data source, and the text is basically going to be a simple div props data text. Just before I'm going to show you how it looks like, I want to add the layout so I can have all the components in the right place. So I'm going to wrap each component with a div, and I'm going to have some styling here. So for now, I want to put each component on the exact place that the user put it in the editor. So I'm going to use position absolute for that. The top is going to be the Y from the layout, and the left is going to be the X. Now I'm going to use position absolute, but maybe in the real world, in a responsive website, I'm going to have a grid here that, based on the width of the screen, is going to decide where to exactly to put the component. But in our simple scenario, I'm just going to use position absolute. Now I just want to put the width and the height of the components. It has to be on the tag, on the element tag itself. So a little bit more styling, the width and the height on the button and on the image. And it doesn't matter for that div, it's not going to matter because only the font size affects the text, so I'm not going to do it. Okay, do you think it will work? Let's see what we have here. Okay, so it works. I render the component, and React basically tells me that I need to have a key for each div in a list. So let's add this, something internal that React wants me to do. Great. So what I actually did here is I took the JSON, the representation of the site, and I basically implemented 3 React components, the button, the text, and the image. And I'm looping the structure of the site and rendering the React components in the exact spot that the user edited in the editor. And now I basically have this JSON representation that I can change. I can change the X and Y here, or our other text here, and it will represent in our website if I refresh it. Great. Any question about our simple renderer before we go on to more complicated things? Great. So now, after we finish the simple site renderer, now I want to run Wix code. What I actually need to do, I need to run the Wix code that will change the IM text to it works. So exactly like the site structure, also the Wix code is somewhere in the internet, and I have a URL to get it. And again, in my case, it's just going to be a simple URL, but in our site renderer, the server sends the URL of the Wix code to the client. So it's going to be Wix code, and it's, instead of a JSON, it's going to be a text. Let's see that I have the Wix code. It's just a string, and so we got this Wix code string. Now, I want to execute this code. So what I could do is I could execute it here, but it might be an issue. And let's to understand why it's an issue, let's look at this Wix code. This Wix code uses the SDK that I mentioned earlier, and it's the way that the user code, basically the user code, is interacting with the Wix website and the components of the website. But why do we even need this SDK? Users can implement the same logic using the browser API or the window API. So let's see an example of that. I could use, I had here a snippet. Great, I could use a simple browser API instead of this SDK, if I put an ID of the component, let's add an ID of the component on the DOM in the renderer. I'm going to have an ID here with the comp ID. So if I had an ID, so users could use the window API to basically change the components. If we did everything correctly, then I'm just running this code, which changes using the window API to change the component inner text. So, and I executed the code in the same context as the window, so the user code can access the window. And if we would do that, so why do we need this SDK? If we do that, if we let users use the window API to change the components of the website, they will have a very intimate their implementation will be very coupled with our internal implementation. Their code will be coupled with our internal implementation. And this will be very hard for us to make changes to how our application works. If we, for example, decide to change the place of this ID to say maybe a wrapper DOM, or to add it to change the string, this will break user code. So we don't want this coupling between user's code and our internal implementation. And it gets even worse if users use classes that we use in our DOM. So we don't want users to use the window API in their code. We want to develop an SDK so they can use this SDK. We can change our internal implementation, but keep the API the same, and then everything will just work. But what if? But we all know, like ourselves, we are all developers, and we know that if we have a chance to use something we know, we will probably use it. So even if we implement this SDK and still run the user code in the same context as the window, people will still use the window API, the browser API. So we want to run the user code in an environment where the window is not defined. So they cannot use the window object to access the site components. So the way to do it is run the user code in a web worker. Web workers are basically the way to run isolated code in the browser. Let's play around with web workers. I'm going to create a new worker here. And the URL is going to be worker.js. Let's see what we got here. So I created a worker, and I got an instance of the worker. It has a few APIs, but I'm just going to use the post message API, which is basically to send a message to the worker, and also the onMessage API, which lets me receive messages from the worker. So the main thread and the worker are both communicating with the messages. So I don't remember if I said it, but the worker is running in a main thread, and sometimes in some browsers it's different process, and the browser promised the developer that they will not share any global memories, and in the web worker, the window will not be available. Okay, so what I want to do now is I want to send the Wix code to the web worker and execute it in the web worker. Before I do that, I want to just send a simple message to the web worker. Let's try that. Hey worker, and now this is going to be our worker code here in worker.js. I'm going to do this worker.js so it'll be easy. And this is going to be the renderer. So just like in the main thread, there is the window object, the window global object. So also in the web worker, I have the self global object, and all the APIs are all the post message API and also the on message API are on the self object. So the on message, this function receives a message. I'm going to console log it and also send a post message to the worker. Hey. So also here, I want to listen to messages from the worker, also back in the renderer code. Okay, so I send a message from the main thread to the web worker, and also I receive the message in the web worker and also send the message back to the renderer. So let's see how it looks like. So the message object is a complicated object, but what I actually care about is the data of the message, also here and here. So let's change it here. Let's change it here. Great. So you can see that hi worker is in worker.js and hi renderer is from the index.js where we write our main thread. So now I want to send the Wix code to the worker and execute it there. So I'm sending this, and back in the worker.js, let's print it here. So in the worker.js, I have the Wix code, so let's first of all remove. Okay, so let's execute Wix code here. And let's first of all see that it explodes, that window is not defined. So like you see, window is not defined. I don't have access to the window in the web worker. And let's bring back this code. And now my code crashes because $w is not defined. So let's look at this API. So again, this $w is the SDK that we give. It's a global object that we pass to Wix code that the user code uses to interact with the Wix website and also change the components. So it's a function that receives a selector of a component, like we saw in the editor earlier, and it returns an object that has a text field, and when I set something to this field, I need to change the data of the component. So let's see how we implement it. So this $w needs to be a global function. It receives a selector, and it returns an object. Let's see, first of all, what I want to do before I return the object. I want to find the relevant component from this selector. So like you remember, the selector is this ID for this. It's kind of like an ID for each component that helps the user code to select a component in their code. And it's stored in each component structure, in the site structure. So each component is in each component structure, I have the Wix code ID. So I want to find the right component, the component that's for this selector. So to do that, I want to have the components also in the web worker. So let's send all the components also to the web worker. I will put them globally so I can access them in the $w function. It's components. Great. Great. So now I want to find the right component from the components array. called Wix code ID. And it's going to be a component. Let's see that I should have here, wait, I should have here the text component. Oops. Okay, so I have here the text component. And what I want to do now, I need to return an object with a field with a text. And what I actually want to do is I want to send a message to back to the renderer and tell him to change the component's data that I have here. So I'm going to use JavaScript setter to do that. It's going to be set text. And basically, this is a JavaScript feature that lets me write the code like this, but it's actually a function that receives this value in the first parameter. So it's going to be this new text. And what I want to do now is I want to send a message back to the renderer to change this component's text to this new text. So I'm going to send a post message here. Let's send the comp ID so I can have, so it will be easy for me to find the component on the other side. And I'm going to send here a data object, so it'll be easy for me on the other side, on the main thread, just to take this object and assign it to the original site structure data object. So this is going to be text, it's going to be new text. So now let's implement in the main thread the function that handles this post message. So I should have here the message that I'm printing. So this is the message that I get in the main thread. It has a comp, so let's change it to comp ID, which makes more sense. Comp ID and the new data that I need to assign to the old data. So what I want to do now is, again, find the components based on the comp ID. This needs to be data. So I'm finding from the components array, I'm finding the component with the comp ID from the data. Let's see that I found the text component. So I found the text component, and what I want to do now is I want to have to basically just object assign comp data, the original data of the component, and data.data. So let's call it override data, so we won't have to write data.data. So I have override data here, and now I'm just taking this new object and assign it to the old object. We don't need this here. Let's clean our code. We don't need this. Great. We don't need this. Great. Okay, didn't work. Any idea why it didn't work? Why didn't we, let's debug it a little bit. Sorry? What do you mean? Re-render. So you're right. Because what happened here is the main thread ran. We created a new worker that runs in a new thread, and a lot of we send a message. The worker gave back a message, but in the main thread we already rendered the components to the site, and then when the worker sent us this message, we basically changed an object, and just nothing happened. It was too late. So will this fix it? Ugly fix, but let's see if it works. Now it works because now we're rendering all the components after we get the message. So, but this is ugly and actually not what we want. But what we do want is we want to separate this code from actually this function. This code gets the Wix code, creates the worker, send the message and receive message. We want to take this code and put it here. We're going to call it platform, and it's going to do all the platform code. And the contract between the platform function and the renderer is going to be that the platform, we're going to call it here, and we're going to wait wait for the platform to finish before we render the component. So because we want the platform to run Wix code, to run the worker to load, and the worker to send back the message to change the component, and only then we want to render the site components. So to implement it, we'll return a new promise here. Implement this code here, and I need to add async here. And I'm going to resolve the promise only after I assign the new components data. Great, so components is undefined. I need components to be globally so I can access it in the platform function. Great, now it works. And this is actually a common pattern that we see in the site renderer, that we want to run logic before we render the components. But we can maybe do stuff like dynamically load code of React components based on whatever is in the page, or do some layout logic here, and do all of that before we render the components, because once the components are rendered, we don't want, obviously, to change them. So this is a common pattern that we have here. We could also wrap this code with an if is user code. Is user code, do I have user code in this site? And if not even load the platform. What if it's just a simple site with no user code? So I can do like this. I can even move this code out of this file and dynamically load it if we have platform, if we have Wix code. So all of those are available to us because we made that separation of the renderer and the platform. But in our case, we're just going to run the platform code. Great. Everybody understand, following what I'm doing here? Great. Awesome. Okay, so yeah.
Quick question. So in that way, you render only once, right?
Yeah.
You wait for the data and then render it.
Because that's what the user wanted. The user wanted to change this text to it works before it shows the previous text. He doesn't want to have this flicker, to change the old text. I mean, that's a part of the product.
But if some of the code would need to wait a second and then change something?
It depends what the user wants. If the user wants to wait if he wants to write his code so that, that we need to wait for him before he renders the components, then we'll wait for it. I mean, really the user code returns a promise, so he can do whatever he wants in the promise, and once he resolves the promise, we will render the components. So he can go fetch data and then change the components. Everything happens. Once he resolved the promise, then I obviously didn't implement it here, but that's really how it works. Great. So now I want to make things a little bit more complicated by adding more Wix code here and talk about this will make us implement more advanced features in our site renderer. So now I want to, so right now what we're doing, we're sending one message from the main thread to the worker and one message from the worker back to the main thread. Now I want to implement more code, so I'm going to move to this new branch. And now I added more code. Now added code that I need to click. When I click the button, when the user clicks the button, it changes the source of the image. So to implement this code, now I want to send more than one message also from the main thread to the worker and also from the worker to the main thread. So instead of having to handle these multiple messages in the onMessage function, of each also in the main thread and also in the worker, I'm basically going to put a type on each message. A type that's going to help me decide which function to run also in the main thread and also in the renderer. So this is the difference between the other branch and this branch. Let's take a look at it. For example, in the worker, I added a type setData in my message, and then in the main thread, it's easy for me to check this data in the onMessage. Simple code that takes the data of the message and call a function with the same type, of a message. You see I have a function here, so it's basically just going to help me write, it's going to be easy to add more types of messages now that I have this code. So I did it also in the worker, and also in the main thread, and also in the worker. But the same logic, I keep the same logic from the last branch, and I only added types and logic that, based on the type, call a different function. And also, another small change, I want to resolve the platform promise only after I finish executing Wix code and not on the first message. Before that, I resolved the promise once I get the first message. Now I want to finish executing Wix code and only then resolve the platform promise. So to do that, in the worker, after evaluating the Wix code, then I send the post message with the type worker done. Only after evaluating all the code, I can do a lot of messages there, and only after that send the post message worker done. And in the main thread, the worker done message just resolved the promise. So this is all the changes between the last branch and the new branch. We added types to messages, and we are resolving the platform promise after we finish executing Wix code. Everybody, is it clear the difference between the two branches? Great, so we can continue. So now I want to run this Wix code. So now I have an error, onClick is not a function. We need to implement the onClick function. So let's implement onClick. So it receives a callback. Oops. And what I want to do now is I want to take this function, this callback function, and put it on the onClick of the button. So when the user will click the on button, I will call this function. That's what I want to do, so let's try to do it. Again, I'm going to follow the same pattern here with the ID. And let's go to the main thread. Oh, I need to add a type here, so let's add a type to this message. It's going to be set event handler. And let's handle this message here. It's going to be a function. The text comp ID and callback. And let's find the component just like we did before. Now I have the components object. And since this components object is passed to the React component, if you remember in our renderer, we passed each structure object to each React component. So this props object that I have in this button React component is exactly the same object that I have here. So I can basically put an onClick function. I can basically put the callback on the onClick function of the button and of the button structure, and then in the props of the button in the renderer, I can add an onClick function here, and from the props, put onClick, or nothing if I don't have a function, so my code does not explode if I don't have this onClick. All right, so a small recap of what we've done. We have the onClick function. We send the function to the main thread, and we put the callback on this object that is passed to the React component of the button, which basically just put it on the onClick of the element. Great. What do you think? Will it work? No. Awesome. Great. So we got an error. And the error tells us that the post message is failed to execute because some function could not be cloned. And if I look in the post message API, I can see that I can only pass serialized data between the worker and the main thread, and also from the main thread to the worker. Only serialized data is allowed in the post message function. So I cannot pass this function to the main thread. But what I can do is I can save this callback in the worker, and under some callback ID. So I'm going to create a callback ID here. We're going to see in a second how we're going to create it. And then I'm going to have this object here. And I'm going to save the callback in the worker under the callback ID. Great. And only send the callback ID to the main thread. And the callback ID is going to be a string that has the comp ID in it, so I can have multiple callbacks for multiple components, and also the name of the event, so I can have multiple events for a component ID. So this is going to be my callback ID that I will send to the main thread. And in the main thread, instead of putting the callback in the onClick, I'm going to put like a proxy function, which is going to send a message back to the worker to trigger the real callback. So it's going to be something like this. It's going to be worker post message. The type is going to be handle event. It's going to get, now instead of a callback, it's going to be callback ID. I'm going to send it the callback ID. And back in the worker, the only thing that I want to change, I want to add the type callback ID. So let's, the handler. Let's implement the handler here. Handle event. It's a function that gets a callback ID, event handlers, callback ID, and I'm just going to run the callback ID. So let's recap. So instead of sending the callback to the main thread, I'm creating a callback ID, saving the callback in the worker. Under the callback ID, send the callback ID to the main thread, and in the main thread, I'm creating a proxy function that I'm going to put on the onClick of the button, that this callback, this function is going to send the callback ID to the worker, and the worker is going to trigger my function. So if you're a backend developer, maybe it's kind of like an RPC, and let's see if it works. So I did not implement them on the source yet, but let's just put any constant. Is it works? Oops, oops, oops. Works, great. So we have this working, and now we want to implement the source, and all we want to do is we already have all the infrastructure ready for overriding data of components, so it should be easy. This set source. I'm going to send a post message from type set data. It's going to get new source and new source. Should work. I have all the infrastructure ready from the set text that we did earlier. If I send a message like this, it should change SRC. Great. This should be SRC. All right, let's see if it works. It didn't work. Anyone has any idea why it didn't work? Same answer. Same question, same answer. Great, so let's see what happened here. Back to the main thread. So very similar to what I said before, we're rendering the component after the user code finish running, we're rendering the component, then the user click the button, we send a message to the worker, we send back a message to the main thread that changes some object, that changes this object, but nobody is aware about this change, and we are not re-rendering the components. So what I could do here is I could extract this function, this code to a function and call it, but I don't want to do it because only one component has changed, and if there are a lot of components on this website, this could be very slow to re-render the entire components every time that one component was changed. So I want to re-render only the image component if that one was changed, and also to have this also again this coupling between the UI and the platform. If I would call a render function each time something here changed, it would couple the platform code and the UI code that I actually want to separate. And I have another. So I don't want to do that, but I have another Another option is to put my state, my components array, on React state in the renderer, and then use set state to set the new data of the component. But that will have the same performance issue, as React will not be aware of exactly what changed and will just re-render the entire components. And also putting my state, the entire state on React state is also not a great idea in a big application. I actually want to separate the UI from the logic and keep my state in my logic part of the application. So I don't want to do that as well. What I actually want to do is I want to use a state management to help me with my issue. So I will import MobX, and I will use the observable function, and I will wrap my state with the observable function. I will wrap the entire components array. So this is going to be components, and I'm going to call the observable function. I'm going to call the observable function with the components array. And what that's going to do, now, my components array will be a MobX object that it's not exactly the components array that we think it is. Let's look at it. So it's basically a very strange object that what MobX does, it loops every field and and all the data of this object. It transforms it into setters and getters, so it will know when I access it and also when I change it. So now I can tell MobX what I want it to do whenever something is changing. What I want it to do is I want it to re-render the right component. So I'm going to go to my render, and first of all, something exploded because now this object is not serializable when I send it in a post message to the worker. So I'm going to use the to.js function to transform it back to regular objects before I send it to the worker. Now we don't have an error. Okay, so back to the renderer, I want to tell MobX, I want to give MobX access to my React components so he could re-render the React component when it was changed. So I'm going to first of all import observer from MobX React. And I'm going to wrap each React component with the observer function. It's going to return a new React component. This observer here, and image. So now instead of the React components that I implemented, now I have React components that are wrapped with MobX React components. And since each props object is also a MobX object, MobX can know that each field that each React component is using, it knows when it was changed, so it can re-render the right component. Let's see if it's working. Great, it's working. Thanks. So basically, I used MobX to manage my state and help me re-render stuff when things changes, and I still have my separation of the platform code and also the UI code, and that really helps me to have this clean code. Okay, enough code for at least for now. I want to recap and tell you that the site renderer that we wrote is still a simple site renderer, but the stuff that we talked about during the live demo, if it's the re-render issue that we kept having during the live demo, the separation between the UI code and the logic code, and also stuff that we want to do before we render because we cannot render and then do stuff, is challenges that we face and things that we talk about all the time in our group, and hopefully it was interesting for you. I put the code in this GitHub repository. So if you want to take a look at this code, you can check it out here. And You can even run it there and play with it. Anything else? I think we're done. Thank you so much. Thank you so much.